Great news for performance enthusiasts. WorkshopFest is back. This year on August the 10th to the 12th. 2 workshops packed to the brim with useful, practical knowledge. August 10th 2022, Advanced Reactive UI Patterns. August the 11th to the 12th, 2022, Performance at Scale, High-Speed Applications on Any Device. Go to WorkshopFest.dev and reserve your spot now.
What's up everyone, this is Dariusz Kalbarczyk, co-founder of MG Poland, JS Poland, AngularMaster.dev and WorkshopFest.dev. Welcome back to AngularMaster podcast. Today we've got a special guest from Vienna, Austria. Performance engineer, trainer, consultant, enthusiast of technologies such as Angular, NestJS, RxJS or TypeScript. He is also GDE and Microsoft MVP. Ladies and gentlemen, Michael Hladky. Hi Michael, how are you today?
Pretty good, thanks. Happy to be here.
Let's talk in detail about the upcoming in the Workshop Fest. I think we will go through the agendas to give our listeners an idea of what to expect.
Yeah, that's maybe a good part, also a good idea to go just top down through the agenda. It is global state as a first thing is, in my understanding, a very, very necessary introduction to the whole topic and why I believe this is so important. You most probably know state management is definitely a core topic for every developer that is not just starting with Angular or any other framework. It is basically a necessity to write stable, bigger, scalable applications. And of course, in every framework, there are libraries. So are frameworks in Angular. There is NGRX, RxState, NGXS, Akita is one of the most flexible ones for global state management I want to name. But also RxAngular, for example, a library that only focuses on local stuff, on component state, especially on component level side effects, but you also can leverage the power for your global state management. But this is not the problem. It's not the problem to understand a specific library. The whole problem that I see in our nowadays developer society, let's call it like this, is that we don't understand the general term itself. So we start and we go like fully fleshed NGRX with 1 million of lines of boilerplate and this and architecture there and there. And in the end, we don't really think very well on what even is global state. Why should I move a piece of data into global state management? Why should I even manage a piece of state? And why not? So this is the whole motivation why local versus global state management is the beginning of this workshop. And I can quickly pitch it to you now, but but I will do that anyway in the workshop. What I want to share today in the podcast is maybe something that I have not so much time in workshops. It is how I even realized why this is so important, and to motivate you to also have a same learning path as I do. I want to tell you a quick story on how I realized what it means to think about state and what other libraries and other frameworks did. And I was struggling already for a long time with what is global state management? Why should I use global state management? What to move into the global state management, what not? And it was a couple of years ago where I started to craft my own how-tos, my own rule set. Back then I had a talk that was called Solid State Management. It was a very general talk on state management. It was focusing a lot on global state in general. some years later, I did a huge research on local state management. I called it ephemeral state management in JavaScript frameworks, front-end frameworks. And during that research, I learned really, I guess, the most. This was the time when I realized how important it is to have it push-based. So a state management system should always be push-based, in my opinion. If you manage state, you should receive state changes automatically. You should not care about propagation and checking them. But even more important, what I learned back then is when you move stuff into the global state and this was my new topic, move stuff in the local state. And I can only recommend to read some comments on Twitter, some statements and blog posts of Dan Abramov, one of the core contributor of React, because, and this is funny, React had a little bit more time on state management that we in Angular, in the latest version of Angular, had. And we basically started state management in Angular by looking to other frameworks, and we looked to React, we looked to this and to that framework. We took over a concept that is called Redux. It's basically a mixture of CQRS and event sourcing from the backend. And we just took it over because it was present in other frameworks. But what we did not realize is that other frameworks, especially Dan Abramov tweeted about it, they had their learnings with global state management, and they realized how painful it is to just use a technology, just use an approach, and what downsides you get. And one of the really interesting things that Dan Abramov said that really changed my opinion, or let's say helped me to even more getting comfortable with my opinions, was he said, if you don't need to share your state, just please don't share it. Don't use it in global state. If it only lives in your component, it's definitely a local state. So he motivated people in a couple of tweets to flip around the opinion of looking from the global state to the local state management. So I want to put it in global state management, and I check if I can put it there. Yeah? Can I put it in the global state or not? What he was telling me, what he was motivating me, and now I'm a really fully convinced advocate of this approach, is start from the component level. Put it in your component and only, and really only, if you have to share it, move it somewhere else. And the whole philosophy of RxAngular state, the package there, is basically from this point of view, we really wrote the whole library, the whole system from a local point, from a point where we have the concept of locality from the beginning in mind, and later on we move it in other places, we move it in the global part. This is definitely one of my biggest learning for global versus local state, that I flipped around my opinion of starting with the global state and going to the local state. And I also, over the time, reduced the complexity of my global state management dramatically. I started to use Akita instead of other libraries, because also NGXS, a smaller version of global state management, produces a lot of boilerplate and is not really helpful, is not really helping you to do the stuff that you really want to do. And it is a lot of overhead. So what I really can motivate is start locally, and also try to avoid big, clumsy, bloated solutions as long as possible. You will not do any developer or the whole team velocity a favor if you start with that too early. That's a story of why I look different on local versus global state management. It's not really distinguishing those two things, but I guess purpose of those podcasts, of this podcast here should not be to like explain everything that I will explain in the workshop, but maybe give a little bit more additional context on why I even picked these topics.
Exactly. The next issue is derived state.
It is definitely very connected to the next one, which is view versus view model, or model versus view model, to be more specific. I guess we can, or we should update this. If you can edit the website right now, you should replace the word view with model, because it is model versus view model. And derived state is very connected to model versus view model. And the derived state is basically a computation process where you take some state and you, let's say you have a list, and in your component, you want to display the number of items in the list and the selected list items and the list itself. So the number of items in a list is definitely something that you derive, that you basically look at the list and say list.length. You don't store the number of items directly in your state, you derive that state. This is the name of the process. You run a computation against your model and derive something new that is only visible in the view. And you can call it view model. I will later on talk more in the next point on view model. But for now, I want to only focus on what is interesting in that process itself. Why? What should I care about if I derive from my model a specific view model? So what I can tell you is, as you consume that model in the view, it is very dynamic. Imagine you hide and show in a collapse box the items. Imagine not all the time the number of items is visible, but maybe only if you have the box collapsed and not all the items are visible. So you want to give the user a hint how many of these items he can expect. Or you want to show the user how many items are selected and so on. So all that stuff can change depending on the state of the view. What does it mean? It means that those computations, in best case, should run lazily, which means only if I need them, only if I display the state, I want to also compute the state. And another thing is, if you think about the collapse box, what if I show and hide that stuff multiple times? And what if some changes in my list will affect this computation, but I want to be as efficient as possible? And therefore, I quickly walk you through the core operators that I would use. From the state before, like what is global versus local state management, I already pitched you that I believe push-based is or a reactive state management system is the way to go. And you can hide your reactivity, or you can expose your reactivity, but in both cases, you should take care about the scenarios that I will mention now. The first scenario is nullish values and only run that computation when you need it. So imagine your state is not set yet. You have undefined as a value. Do you really want to run a computation against nothing? Definitely no. So if you have nothing, why should you compute something? So this is what I mean with nullish values. Only compute your stuff if you have something. And later on, if you think about a fully reactive with RxJS reactive state management system, if you subscribe to that stuff, you should not trigger the full evaluation of everything front off, but only if there is a value present. So this is the nullish value thing. And technically you could, if you think about RxJS, technically you would just implement a filter that filters out undefined values. And then you basically would not run a computation against nothing. The second thing is you have some changes that affect your computation, but it will not affect the outcome of the computation. So imagine you have a function that computes 2 plus 2, and And that gives you the outcome 4. So with the new value 4, you definitely want to boom, update the DOM, re-render everything, trigger change detection in Angular, and do all that stuff that is necessary. But imagine at the very next moment, you compute 1 plus 3, a completely different computation, but the outcome 4 is the same. So with that in mind, you definitely have nothing new to show to the user. You do not need to run change detection again. You do not need to do all the computations again, because it is not a different result from your computation than before. In real life, in, for example, RxJS, you would just only forward distinct values. And there is an operator that is called distinct until changed. But you don't need to run work with RxJS always. You just need to understand what distinct values are, and that you should only forward distinct values in your change queue. And the last thing is shared computations. What if you have multiple different places in your component where you want to display this result, the number 4? You definitely only want to compute 2 plus 2 one single time. And if another place in your template also wants to consume the same result, the same computation, you should just forward the result and not recompute everything. And this is basically the end of my answer to derived state. And now we can talk about model versus ViewModel, where we have this typo here in the website that says view versus ViewModel. We want to talk about model versus ViewModel. Imagine we already have our global state and our local state well defined. We know where to put what, and now we ended up, after traversing all the components and all these tree structures, to the very component we want to manage a specific state for this single piece of code, for this very own component. And this is our model, the component state, you can call it, or the model that lives in our component. This model should definitely only include data that you really need. And if we now think about the example from before, where we maintain a list of items that we can select some of them, and we want to display the number, I can give you quickly an idea on what would go into global and local state and what would go into our model. And the second part, what would go into our view model? What would be the state that I need to derive from my model? So we have a list of users. This is definitely stored on the server side, and these users are displayed on multiple different places in our application. So this is definitely the global state. From these 100 users that you maintain in your application, you want to select all the, I don't know, let's say all the users or the attendees that visit our Workshop Fest. This is definitely a subset of users, and this subset of users is only displayed in the very component Workshop Fest users. And those users you want to display, you want to say, hey, we have 75 attendees for the Workshop Fest, and hey, we want to select the, I don't know, the ones that attend or that are very interested in performance, and the other ones that are very interested in architecture and global local state management, and make 2 groups out of them for the 2 workshops. The subset itself is already local state. The subset of people that attend the Workshop Fest is already only managed in the component or in the container, but let's keep it simple for now and let's speak about component only. So this is definitely our local state. It will not get managed in the global state. It is just a derivation of the global state. And here we have state derivation already in the game. Give me, hey, global state, give me all the users from NG Poland, but now I want to have a subset. Give me all the users that attend the Workshop Fest of NG Poland. So a subset, a computation that I run, and whenever my global list of users change, I could recalculate that subset, and if there is a difference, I would forward that subset to my component, and my component would do whatever the component does. So this is the derivation from the global to the local state. Now we live in the local state in my component, and we can make another assumption, another distinguishable mindset on what we maintain in the component and what we display. So what we maintain is the list of users. What we display is a list of users with checkboxes, the first and last name, and next to it a checkbox, and maybe also the total number of attendees, for example, 75. So my question, what of those three states do we need to maintain and what not? And I can tell you what we need to maintain in our model. And the model is basically the essential normalized, if you think about databases, the normalized state of our state that we want to display in the view, our view model. So in the view model, we have all attendees and this and the first and last name of it. Maybe there is more data available for all these attendees. First name, last name, date of birth. And this is definitely maintained in our component. So this is the model. And we display out of this model just the last and first name of the attendee. But the list of attendees is definitely model. Then we have the number, the total number of attendees. And we said, okay, the list consists out of 75 attendees for that workshop, users for that workshop. And this number we don't need to store in our component all the time because we can just derive that for the view only. So we would generate a second object, and whenever the list changes, we can also recalculate the list, the number, like the list items, the list length, the number of attendees, and then we can forward that to our view. And now I again want to speak about derived state. So imagine we update the attendee list and we update the birth date of somebody. If this happens, our state derivation for the view would trigger, and we would calculate the new attendees, first name, last name, and the new number of attendees. And then we would realize that for our view, we don't really need to update anything. We don't really need to re-render anything because the name, first name and last name did not change. And also the number of the attendees is the same, 75. This is a very good example why distinct values make a difference. In a normal application, in an application where people would not consider this technique, and this is basically, at least from my understanding and my checks that I do constantly, the case in any other library. Akita, they are all global state managements, but for example, local state management systems like my implementation in NGRX, the component package or the component store there, they don't really think about those scenarios, and they would trigger a re-rendering of the full component. And this is the reason why I say, if you do a derived state, you should think about those three concepts: distinct values, nullish values, and shared computation. And you forward that to your view model. A perfect scenario where you don't need to write any additional code for that would be if you use RxState. The selector principle there already implements in a very nice way, without any additional code and no boilerplate, that you can just select state and it will automatically forward only distinct values, hide nullish values, and share the computed state to the view model. And this is basically the connection between model and view model, the computation and the way how you display different things in the view, then you maintain. So what you maintain is basically the list of users, maybe the IDs that are selected, but not the number of items and not anything else that you want to display in the components template, in the components view model.
You're listening, Angular Master Podcast. Listen, code, repeat. Everything you need to know to become an Angular super developer.
Our next topic is design patterns.
It is already a first design pattern if you distinguish between model and view model, but there is more. I will elaborate, I will talk on that a lot more in the workshop, but we can now take well-known object-oriented design patterns that we know from the past and apply that in Angular, for example. And there are a couple of those design patterns that we use at the moment, but not well define it. And then there is a couple that we can use now with these new principles and with basically all the information that I had in my ephemeral state management resource, and with all the features and all the hidden tweaks that are implemented in, for example, RxAngular, but I hope in the future also in other libraries, because they are very, very helpful. So what design patterns can we use now? We can use the Facade. The Facade pattern is basically a perfect fit for container components that try to abstract a little bit of logic and make a nicer API for us to consume. And a Facade pattern is really a very generic pattern that you can apply. I would even say, try to forget the Facade pattern and try more to think about the adapter pattern. So the adapter pattern is even more closely related to state management, because the adapter pattern adapts one thing, one interface to another interface, adapts a US power plug to a European power plug, or any other power plug adapter that you might know, is a very nice metaphor for what we do with a adapter pattern in programming. And what you will end up is you have a certain state in the global state management. For example, you have a list of users with first name, last name, if they subscribe to the newsletter, what their birth date is, and so on. And you want to only have a subset of that specific users, maybe only first name and last name, in combination with some other state slice, for example, if they are selected for a specific workshop or not. And this is adapting one piece of state, one interface, one typing to another typing. And this is identical to how I try to write my applications. I only want to expose data types. I don't want to expose too much methods. I just want to expose streams of data. And in between, I just map one data type to another data type. And this mapping I hide in my container component, where I instantiate another service. And this is then my global to local state adapter service, which runs the transformations again against the changes from the global state and forwards it to the local state. And all the logic is completely hidden, and I just consume change sets. I just consume streams of data that changes over time. And this is how I try to work with it. So those are patterns, object-oriented design patterns that you can use from more global or service-oriented, or let's say more macro architecture. Now we can also go to micro architecture, and we can talk about the MVC or MVVM pattern, and the model view controller or the model view model pattern are very nicely applicable to the component structure, to user interfaces. And we most probably already know MVC patterns from AngularJS, also from how we use Angular nowadays. But we can do even cooler things now. We can basically also try to think about the MVVM pattern, the model, view, and view model pattern. And with model versus view model, I already pitched this architecture pattern, this micro architecture pattern, drastically, I explained already a little bit that we want to maintain a different model than we want to display in the view. And this is the whole concept, that you have a model, the view, and a dedicated model that is only here for the view, and this is called the ViewModel. This is the last of the 4 architectures or object-oriented design patterns that I would pitch you in that workshop. Of course, there is more. I mean, you have also the commander pattern, you have plenty of other stuff, but this goes more to the macro architecture, and I really try to not overload us with a lot of different principles. I try to make it as on spot and as useful as possible.
So now let's talk about observable inputs without decorators.
Observable inputs without decorators, and the next that I also want to include in that question is the next line, observable HostBindings. These are just missing pieces that we need somehow in Angular, at least, to have a nice and smooth way to connect things, and especially when you want to think about performance, but also when you want to just reduce the number of lines of code, you can think about the technique that I pitched 1.5 years to 2 years ago, which is forwarding observables directly. This is an essential architectural pattern that I would suggest to you. If you are already familiar with the change detection on push strategy, you will, if you understand it, love it, because change detection on push is basically re-evaluating a component only if you have an input binding that changes. And now imagine you combine that technique with observables. The observable itself that you forward will never change. Only the internal changes that you forward with this same observable are changes, and you can now eject, or let's say exclude, this component from change detections completely if you pass the observable and forward changes through the observable, and you get back to updating and detecting changes whenever you want to. And this is in best case done in the view, of course, but you could also think about some less performant architectures where you trigger change detection in the component. Still valid for especially small components, and definitely a thing you could consider. If you want to run with that technologies, with that architectures, you should find a way on how you take this observable inside of your input bindings of your component, and therefore, in best case, you don't use a decorator. You can write your own decorator, but in best case, you use it without the decorator. And a concept that I will pitch in the workshop on how to handle it is that you connect these changes directly to your component state. One implemented, fully tested approach where we don't need to spend a lot of time to implement it in the workshop will be RxState in combination with the connect operator. But of course, as I focus on a very library agnostic way, we will also see how to do that without any other library.
Michael, next topic is managing async data streams with RxJS flattening operators.
You most probably know the switch map operator, because this is from the beginning the most confusing RxJS operator in Angular itself. Of course, there are way more confusing operators, but I would call switch map the most famous operator in the Angular ecosystem. And switch map is a flattening operator. It basically takes a HTTP request, which is a full process on its own that has a start and an end, maybe an error, and it is able to take multiple of those processes and flattens those process results together into one result stream. So you have multiple search requests, but you have only one search result in the view, the list of attendees, the list of workshops that you want to search for. So this is one of the flattening operators. And in this chapter, in this theoretical chapter, I want to talk about all the other different flattening operators, which is not only switch map, but also merge map, concat map, and exhaust map. And I want to give you some more theoretical thinking on where you can use it. I also want to motivate and emphasize that you can also use those operators in the component, not only in the global state management to handle HTTP requests. You can also handle button clicks, inputs from input boxes, and so on. And yes, this will definitely be one of my motivations when we will speak about RxJS flattening operators.
Okay, but how to handle error?
So I would not only talk about how to handle errors in the template, but I would also think about handling complete and suspense states in the template. I coined the term reactive context a couple of years ago, where I say you not only have a value, you have contextual state to that value, reactive contextual state, which is the suspense state, like the time when nothing happened so far, or the time in between the old and the new value. I call that time or that state suspense state. It's an in-flight state. Then I can also name the complete state, where you finished a process and the user should get some feedback on if you are finished or not. And then you have, of course, the error state. And those are the three contextual states that I want to pitch to you, and of course, how you can handle that in the template. A colleague of mine, Julian, had a very nice talk on that topic on one of our recent meetups in Vienna, where he really pitched all those states and how we can leverage them. And he created a very nice pull request on the RxAngular library, where he basically demonstrated how powerful and easy to use those concepts are if you provide them in a meaningful way. And this will be released, I guess, this week. At least we try to release it before the workshop, so that we can also demonstrate a fully implemented, fully tested version of all this theory that I started to present. So we can assume a couple of different exercises on that topic, and it will definitely be one of the most modern use cases, most elegant ways on how you can deal with all those problems in Angular so far.
Okay. What about component lazy loading?
What about component lazy loading? So
yes,
in general, I can tell you lazy loading components, especially with the latest release of standalone components, is a fancy thing that you should 100% consider in your application, especially if you want to save some bundle size, give better user experience, and so on. And it is starting to get to the direction of performance. So component lazy loading is definitely a performance technique, but not fully focusing on performance. So I moved it into this package where it is more of a reactive concept, I would say. And what people do nowadays when they lazy load components or any other thing in Angular, they use async await. They use async await directly in the component, and what is happening when they do this, they will instantiate the component and they will immediately fetch the data. And this is, of course, not really good. What we want to do, like lazy loading, it's funny, lazy loading includes the word lazy already. So what we definitely want to do is we want to trigger the loading of a specific component lazily and not right away when the component bootstraps. We maybe want to lazy load the component only if the user interacts with a specific part of my component. And there is a very well-known pattern. A lazy load on interaction is one of the patterns, or you have also loading facets. You, for example, have a YouTube player, and only if you hover over the play button, you lazily load all the other necessities that you need to load for playing that video. And this is the lazy when it comes to lazy loading. So the async await immediately loads it and avoids any type of laziness in your component loading strategy. And this is extremely boring and not really funny. So what we provide with RxAngular is a one-liner how you can lazy load your components without even thinking about it. Of course, again, I want to present a very library agnostic workshop, so we will only have a quick look on how you can do it perfectly and without any other boilerplate with RxAngular, but we will also see and implement on our own how you can do it manually without the use of any other library, but not using async await at all.
The last part of this chapter is improving UX with reusable reactive helpers.
It goes again into the direction of performance optimizations, but also not really fully focusing there. So let's quickly get a clue on why we even care about making things different. There is the UX. We want to improve the UX. We want to make it better, a better experience for the user. And if we want to make a better experience for the user, we most probably will end up with very repetitive patterns for user experience. And what I want to show you is how real life implementations of user experience patterns can look like and how you could reuse those snippets, those really nice user experience patterns in the wild and save yourself a little bit of headache and time by just looking at my source code or just looking at the examples that we run in the workshop, and save that, share it with your colleagues in your company, and really save a lot of time to implement or let's say to figure out all those patterns immediately. And there is, I mentioned it before, there is the load on interaction, there is a UI facet pattern, there is a lot of derivation patterns that you can use. There is a lot of things the user experience can suffer where you just need to do small tweaks on when you consume the data. You can also deal with loading spinners. This is very closely related to how to handle error complete and suspense, the reactive component, the reactive state, reactive context, and all of that stuff will get elaborated with source code snippets, with reusable patterns that I want to demonstrate.
Michael, thank you very much for today's recording. In turn, I invite our listeners to visit WorkshopFest.dev. Just go visit the site and reserve your spot now. Finally, please subscribe to our podcast, leave a like and a comment to help us continue to grow.